solve. It can be graphed with an equation, or can solve with a graph, I guess. And this is going to kind of try to get us to that point, okay? So whenever, here's the idea. This here, 6.1, is going to provide us with a tool that allows us, when we get to 6.2, 6.3, and 6.4, to check our answer, or maybe even find our answer before we do anything, okay? Ultimately, what this is going to do is it provides us, hopefully, the understanding that no matter what equation we ever come across, in whatever math class, if we can graph the left side of the equation and the right side of the equation and see where they cross, the place that they cross is the solution to that equation, okay? So hopefully we're going to try to build that foundation and then build upon that in the next couple of days. So we're going to talk, this chapter is about things called systems of equations, okay? Now, what a system of equations is just a fancy way of saying it's a group of equations, okay? A group of equations. Could be 2, could be 3, could be 4, could be 100, doesn't matter, okay? We're going to primarily focus on 2, okay? So whenever you see the word system or systems of equation, they're just talking about 2 or more equations as a group. Does that make sense to everybody? Yeah. Okay. A solution of a system, okay, is an answer, and it's essentially an ordered pair. It's an x comma y that makes both systems true, or both equations or all equations in the system true, okay? Another way of saying that, another way that you're going to see that in text is to say a solution is any point that satisfies all equations in the system. You remember back to chapter 1 and 2, the word satisfy meant makes true, okay? So I just want to make sure that we see all this terminology, because on the end of course exam, they're going to use the phrase system of equations. They're going to say, here is a system of equations, or develop a system of equations. What are they asking for? They're asking me to write 2 equations, or 3 equations, or whatever, okay? There's going to be a multitude of ways that we find these solutions. Most of those ways are algebraic. We call them analytical when we ever would do the algebra, go through rules. The first way is going to be graphically, okay? So graphically is going to be the easiest way to find a solution, but there will be times where the graphical approach maybe doesn't make a whole lot of sense to use. Maybe it's graphing of some of the lines might be nasty, and it might make more sense to use the algebra version or approach, okay? Yes? Take a test. All right, so the solution, graphically speaking here, the solution of a system of linear equations, or the solution of a group of equations, is where the 2 lines intersect, where the 2 graphs cross each other, okay? So the point of intersection will be a point on each of the lines within the system. So what I've got here, just as a quick demonstration for us, we're going to graph. They're going to start us off with just the equations. They'll have a blank graph, and we have to actually do what we learned in chapter 5 and graph the red one, and then do what we did in chapter 5 and graph the blue one. And once we do that correctly, we should be able to see where they cross. Where do these 2 things cross?
Right there.
2, 4. Okay? So 2, 4 would be considered our solution to this system. Okay? So what that means to us is at that point, would you agree, that point 2, 4 is on the blue line?
And the red one.
And it's a point that's on the red line. So, and it's the one and only one point that is on both, right? Okay? So when I plug in into this red one, we go y equals says y equals x plus 2, right? I'm going to plug that point in for these values. So the y value is 4. The x value is 2, right? Is this a true or false statement here?
True.
That's a true statement. 4 equals 2 plus 2, right? That's the idea that that point satisfies the first equation of the system. Okay? The next thing I'm going to do is I'm going to plug that point into the blue equation. So I have y equals 3x minus 2. So y is 4, x is 2, and we'll subtract 2. What's 3 times 2? 6 minus 2, 4. So is 4 equal 3 times 2 minus 2? Yes. So that's another true statement, right? This is true. Both these ultimately break down the same 4 equals 4. Any other point that I choose is going to give me a false statement in one of those. Does that make sense?
Yeah.
For instance, let's take this point right here. If I plug in negative 2, 0. Negative 2, 0 is on that red line, right?
Yeah.
So because it's on the red line, it's going to make this true. If I put negative 2 in for y, negative 2 in for x, negative 2 in for x, and 0 in for y, does negative 2 plus 2 give me 0? Yes, so that's true there. If I plug in x to be negative 2 over here, 3 times negative 2 is negative 6 minus 2 again, negative 8. Go the other way, negative 8. Okay, so that would say 0 equals negative 8. Is that true? No, it's false. And it makes sense that it gave the blue one false because it doesn't show up on the blue line, right? Anything that you find on that red line is going to make the red one true and the blue one false. Okay? Anyone that I find on the blue line is going to make the blue one true and the red one false, right? Except for the 0.24, because that's on both of them, right? And that's going to make the red one blue or red one true and the blue one true. What if I chose a number like 3, 1? What do you think that's going to do?
3, 1?
Is it on either line?
No.
No, so it's going to make the red one false. It'll make the blue one false. That kind of makes sense? Okay. So we're looking for, no matter how many lines we got up there, we're looking for the one point that makes them all the equations true. Okay. Now, like I said, a system is a group, and it doesn't define how many have to be in part of a group. We're going to look at mostly one equation, or sorry, mostly a system of 2 equations. But you can add another equation to that. You can add as many as you want. We can have 3, 4, 5. If we can do it with 2, and we have one solution, the hope is we should be able to do it with 3 and 4 and 5. Okay? So that's kind of what this is structured towards. All right? So I want you guys to take a minute. From chapter 5, on this next example, I want you to graph those 2 equations. Graph y equals 2x plus 4 and y equals x plus 2. All right, so that first one, what's my y-intercept? 4. And then where am I going to go from there? Up 2 over 1. Now, when I go up 2 over 1, because the graph I gave you, is that a problem? So where should I go? Down 2, over 1, which way? To the left. So down 2 left, down 2 left, down 2 left. Huh? So we graphed the y-intercept, which is 4, right? Okay. And we said rise is 2, run is 1, right? When I go up 2 to the right 1, I run off my graph. Isn't negative 2 divided by negative 1 still 2? Is a negative divided by negative still positive? So I can make a rise of down 2 and a run of left 1, and it be the same thing. And it gives me that line. Okay? Now, doing this by hand, obviously my line looks kind of cruddy, right? Some undulations in it, some ups and downs, not all that great. And that can, at times, be a problem when we want to see where these things intersect. Okay? So my suggestion to you is to, one, either like get a straight edge, like a ruler or something like that. Take your time to graph these. The less human error, the better your conclusions at the end are going to be. And I'm going to give you something here in a moment that will help as well. And then this one here, this bottom one, what's my y-intercept there? Up 2. And now we're going to go from there. Up 1, over 1. And I can also go down 1, left 1, right? Line kind of stinks, but you get the idea. All right, so where do those two lines cross? Negative 2, 0. And now here's the thing is that my graph, because of the human error, mine looks like it kind of intersects maybe just above that, right? Okay. But negative 2, 0 is the correct solution. Jaden, please stop. So negative 2, 0. So now let's check that in the blue one. If I plug in 0 and then plug in 2 times negative 2 plus 4, does that give me 0 equals 0? That makes sense, everybody? Plug that into that equation. Is that a true statement? Does 0 equal 0? Yep. What if I plug it into this one? I get 0 equals negative 2 plus 2. Is that still 0 equals 0? Is that true? Yeah. So it's true for both. So there's the kind of the algebra check that is confirming basically our graphical check or our graphical question. That makes sense? Now I'm going to give you, I'm going to email this to you. Spend a little bit of time during lunch kind of creating this. Okay? Yeah. Sometimes you can't.
I'm not gonna.
Huh?
That's my eating time.
I said I created this during lunch.
Oh, I understand. Our lunch.
So yeah, I gave my lunch up for you so I could get this made for you. Okay, so 2 lines here in Desmos, and I can share this URL. So I'll send the URL in your email. You'll click on it, and it's going to pop up this version of Desmos. Okay, and what's going to allow us to do is grab these points and move them. Okay, so that point located at 4, right? That's my y-intercept on my top line. And then we went down to left 1, right? So I can graph that. Does that make sense? The other one had a y-intercept of 2. And then what? It was up 1, over 1? Do you see there, then, that there's no human error involved in where those things intersect? Yeah. Okay? And my hope is, even though we're not graphing it by hand, the hope is that we still go through the y-intercept and then applying the slope process to get the graph, and then you can visually see where they cross. Is that okay with everybody? All right, when you open this is going to be expanded here. Okay? Do not mess with any of this stuff that's in here. Okay, that's the coding essentially to allow these lines, points to move, and you to pick them up and slide them around. Okay? So my suggestion when you use this, just kind of close that off, and then all you got to do is pick those points up and move them around. Does that make sense? Okay. So I'll send you that URL here towards the end of the period. All right. So there's some things that, some textbooks will get in this, some teachers will get in this. I think it's important to see this because for some of us, this will be able to quicken the process for us. Okay. There are 3 things that lines can do. When you have 2 lines on one graph, there's 3 things that they can do to one another. They can do what we've got going on there in that first picture, and they can cross. Okay? And it's going to give me one solution. Okay? Just like the 2 we've done already. Okay? If that's the case, the slope of this line would be negative, right? The blue one? The slope of this red one would be positive. Okay? Now, I'm not saying that they both have to be, one has to be positive, one has to be negative. They could both be positive, they could both be negative. You can have a combination of them. But what I'm trying to get at here is, would you agree that this blue line slope is different than that red line slope? If you have 2 equations, that's what this says in this text box here at the bottom. If you have 2 equations and their slopes are different, two equations and their slopes are different, then your lines are going to cross one time and only one time. Okay? Is that okay there, everybody? So there's a category of questions that'll say, how many solutions do you have? Before they ask you to do anything, and this might even be just the overall question, how many solutions does this system have? 0, 1, or infinite? If they have different slopes, there's going to be one. Okay? This one here says, and you can't really see it on your paper, it's like a really dark line, hopefully, on your paper. But if you get up close to here, you can see like a red line in the back and a blue line over the top of it. Okay? Basically what we've got is two lines, a red one and a blue one, intersecting everywhere. And the way that we argue what that means to us is lines intersect everywhere, thus the equations are the same thing. Okay, the equations that they gave me, I graphed one, then I went to the other one, graphed the second one, and they produced the exact same line. So it's two lines on top of each other. Does that make sense? So they crossed everywhere. They're the same line ultimately. Okay? You say if you put both in y equals mx plus b form, they will be identical. Okay, now here's the thing. If they give me a system like this, like y equals 2x plus 3, and another one that says y equals 2x plus 3, are you going to graph those two things the same way both times? You should. They're the same thing, aren't they? So my hope is that you see that when you graph the green one and then graph the blue one, they should land on top of each other. So it's kind of a trivial example that you're not going to see very often them ask you to graph. What they're going to ask you to do is something like this. They're going to say maybe y equals 2x plus 3, and then maybe the other one will be like 2y minus 6 equals 4x. Now when I look at those, they look completely different, right? But they look different because they're in different format. Let's put them both into y equals mx plus b. If I put this red one into y equals mx plus b, what do I have to do first? Add 6. So I get 2y equals 4x plus 6. Now what? Divide everything by 2. Does it really give me the same thing I started with? That kind of makes sense? So even though they're going to give me one version, y equals 2x plus 3, and the other version, 2y minus 6 equals 4x, they are indeed the exact same equation. Is that okay with everybody? So they're going to give you those types of things. And they might ask you, here are two equations. Are they the same? So you have infinite solutions, or are they different? So you have 0 or 1 solution. Here they're identical. Okay? Might take a little bit of algebra to get to be able to make that argument, though. Okay? One of the easiest ones to see is something like they say, like y equals 5x plus 10, and then the next one they say, like 3y equals 15x plus 30. What have I done to that first equation to get the bottom one? What do we multiply the y by to get 3y? 3. What do I multiply 5x by to get 15x? 5 times 3 gives me 15, right? What do I multiply 10 by to get 30? 30. I multiply everything in the top one by 3 to get that bottom one. And when I do one thing to the left-hand side, and I do the exact same thing to the right-hand side, it maintains equality. It keeps the equation the same, right? Even though it looks different. So whenever you're able to recognize that one equation is a multiple of another, they are indeed the same. So just kind of prove this to you real quick with a picture from Desmos. If I go to, let's see here. If we go to y equals 5x plus 10, and then I go 3y equals 15x plus 30, do those two lines coincide? Are they the same thing? Yeah, and it's because this one is just 3 times as big as this one. That makes sense, everybody? All right. So I guess everything is 3 times as big. So because everything is 3 times as big, nothing changes. So So those are all little relationships that we need to be able to recognize. This next one says that you could possibly have no solutions. So no solutions mean your lines have to be geometrically parallel to one another. Does that make sense? What did we talk about last week? That the slopes had to be if lines are going to be parallel. Opposite meant they're going to be opposite. Reciprocals meant they're going to be perpendicular. If they're going to be this parallel, let's say that you are slopes are the same. Okay, so if I look at this one here, if I go from that point to that point, don't I have to go down one, right two? If I come up here, is that down one, right two there?
That's right one. Wait, right there.
Down one, right two, right? So down one, right two. So my slope would be negative 1/2 in both those, right? If your slopes are the same, then your lines are going to be parallel. Does that make sense? And if they're parallel, then you have no crossing, no intersection, so no solutions. Okay? Now that's a little bit maybe misleading when I write something like this. Y equals 2/3 x plus 1, and y equals 2/3 x plus 1. If you look at just the slopes, you might say, well, those are parallel. If I look at the plus 1s, doesn't it really mean that those two lines are the same thing? So if I look at those two equations, how many solutions do I really have there?
0.
How many are these two equations the same thing?
Oh, this isn't it.
So we're going to have infinite. So they're the same thing, so it's going to give you that situation there. What if I did this? 2/3 x plus 11 and 2/3 x plus 1. Are those different equations? Yes. Are they the same slope? Yes. So they are parallel, right? So no solutions there. No intersections. Okay. So those are little things that I think are going to be important for us to pay attention to. And in the end, they're going to help us, I think, realize maybe some solutions before we even do anything. Okay? So that's kind of where I want to jump all the way to the bottom. I kind of have these in a kind of a poor order. Let's do the story problems last. Let's go all the way to the last thing on this this handout. And I want to just look at these things and talk about the solutions and then graph and see if those solutions make sense to us. Okay? So if I look at that first one, y equals x plus 4 and y equals x minus 3. First thing I want us to see, are those equations different?
Yeah.
Yes, so they're going to be different lines, right? Now, is there a relationship between the slopes that you recognize?
Oh, yeah, they're x.
Same slope, right? They both have a 1x, okay? So what does that tell me? If they're different equations, but the slopes are the same,
That's parallel.
they're parallel, so how many times are they going to intersect? They don't, okay? So 0 solutions here, right? So 0 solutions, but let's graph them, okay? One thing you might see, I don't know what notation Math Excel uses. They might have that with the circle with the slash through it, means no solution or means empty set. You might see that, but if I graph this top, I'm going to do it in blue. What's my y-intercept for that top one? 4. And my rise over run is up 1 over 1, right? To the right. It's positive 1, right? Okay, so we should be able to sketch that line that goes through all those points. And now let's do the bottom one. Do the bottom one in red. What's my y-intercept on the bottom one? -3. And my rise? Up 1, and then which direction? Right 1. So up 1, right 1, up 1, right 1. Can I go down 1, left 1? And does that then confirm our belief that there should have been no solutions? Yeah. Okay. So you can kind of see the situation where we're going to I don't want, I guess what I'm trying to say is I don't want to look at the equations in isolation. I don't want to look at them all by themselves without any graphs. And I don't want to look at graphs in isolation and just look at them without their equations. Does that make sense? They should be intertwined. They should be interrelated and kind of view them that way. Let's look at this next step. If I graph that, so let's just look at them first before we do anything. Are they the same equation? No. Okay. So that means they're either going to be intersecting or they're going to be parallel, right? What do you recognize about their slopes?
They're the same.
They're different, right? 2 is different than 1/2, right? Okay. So the slopes are different. Therefore, the lines are going to intersect. And it's going to intersect one time, right? So we should get one solution. Yours do not intersect. So let's see what we did then. So what if I go up here, +4 is my what? Line intersect. From there, you're going to go where? Up to, right where?
1. Just 2 over 1.
2 over 1. So up to, right 1. Can I go down to left 1?
Yeah.
Now, I put a lot of these points. You guys don't have to put all these in here. I do it because it's easier for me to kind of visualize then where they intersect. Make that line a little bit better, more accurate.
There's no line.
Up 2 over 1. Yep. So I'm looking at the 2x plus 4 one, right? So I go first plot that point right there at 4. And then count up 2, and then right 1. And that will create that line, right? But then I just go, to get more so I can graph it a little bit better, I go down 2, left 1, down 2, left 1. I keep doing kind of that staircase approach to get that line. Is that all right? All right, so now the bottom one.
I did that.
The bottom one, what's your y-intercept there? -2. And now what's your rise or run? Up 1, right 2, right? Up 1, right 2, up 1, right 2. Now here's my issue. Like if I do that, yeah, I got enough points there to create my line, but I don't have it. I'm not using a straight edge back here. And if I keep going to the left here of the y-axis to graph this red line, I'm not going to be very accurate. Like I'm not going to just keep going like that. Does that make sense? Because it's not accurate. So what I'm going to do is I'm going to go down 1, left 2, down 1, left 2, and now it's a little bit more accurate. Does that make sense? And now I can focus on what that ordered pair is. What is that ordered pair? -4, -4. Okay. So what's that mean to us? If I plug that number into both those equations for x and y, both of them would say, yes, this is true. We get like, you know, what am I going to get if I plug in that top one? -4, -4. I get -4 equals -8 plus 4. Well, that's -4 equals -4. Okay. Now the one on the right. Now just think about how, and this is just something to kind of keep in mind. The one on the right?
I'm at 1 and 6.
On the one on the right?
Yeah.
So which one you do? Top one?
I don't know if it's what the line is the bottom.
Okay, because it's not in y equals mx plus b form, right? Okay. So here's the thing. This one is going to, what we want to do is we want to look at this and say, can I take and look at those two things and recognize interrelationships?
Yeah, it's times 3.
Okay, so that bottom one is 3 times as big as the top one, right? Or everything is 3 times as big. So if I multiply this y by 3, I get that 3y, right? If I multiply this 3x by 3, I get 9x, which is that right there, right? If I multiply -1 by 3, I get that, right? So if I look at these, they're really not the same yet, because I got 3y.
-1 times 3 is -2. Very wrong.
But does that look just like that right now? Where's the 3y isn't by itself up here, is it? What do I have to get? What do I have to do with this plus or this -3 right here to make it look like this? If I add 3 to both sides, does that now look just like that? So what does that mean to me? They're the same exact line, so I got infinite solutions. Infinite solutions. So I don't know if that's the best route, guys, to kind of view. I think sometimes, if I give you like y equals, what was it, 3x minus 1, and then I tell you the next one is 3y equals 9x minus 3, I think there it's easy to see that one is 3 times the other, right? But there's some other order of operations kind of taking place here. I think the default thing I would do is change everything into y equals mx plus b. So that means take this bottom one and rewrite it as that, right? It'll be minus 3. And now can I divide everything by 3? And you get y equals 3x minus 1. Is that equation now the same as that one? And if you graph some minus 1, my y-intercept, up 3 over 1. If I graph that in red, and then I get the same thing right here, right? If you graph that differently, we've got big problems, right? If I give you 2 equations that are identical and you get 2 different line equations, or 2 different graphs that are different, we've got an issue. That means you don't know how to graph lines, right? So if I graph 3x minus 1 again in blue, it's going to be right on top of that red one. So this would be infinite solutions. All right?
Yeah, are we done?
No!
Why?
Got a story problem to do. The alligator one. All right. All right, do you guys remember a couple days ago I talked about I take my daughters to the Y and we got to pay classes and stuff like that, and we want to know does it make more sense to buy the membership or to just pay by class that we attend? And what you'd have to do to actually make that decision is to see where they end up being equal. How many sessions do I need to go to where the membership approach costs the same as paying per session? Does that make sense? If I can find out where they're equal, then everywhere else I know where they're unequal, and that's going to be what then drives my decision. Okay, it might be you got to go to 7 classes for them to be equal. That means maybe less than 7 classes. It makes more sense to just pay the class session, the $35 every 6 weeks, something like that. Okay, but after 7 months or 7 sessions, it might make more sense to actually purchase the membership, because then after that, on the 8th one, the 9th one, the 10th one, I will be saving myself money. Okay, so this is kind of the same thing, except for instead of talking about money in classes, we're talking about alligator weights in months. Okay, so scientists studied the weights of 2 alligators over a period of 12 months. Okay, so they're talking from birth to birthday, 1 year birthday. Okay, so the initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same amount? So this is then, of course, exam type question where they're going to tell you this scenario, but you got to write the equations, and then you have to, from those equations, come up with the answer.
That's stupid.
Now here's the thing: if you write your equations wrong, your answer is going to be wrong, right? Okay. So it says let y be the alligator's weight, y be the alligator's weight, and x be the time of months that have elapsed. Okay. I want you guys to take a minute and see if you can come up with those 2 equations by yourself. Okay. Don't graph them yet, because if yours are wrong and then we got to graph them, you got to erase everything and erase your graph and all that kind of stuff. So just come up with the 2 equations. All right. When it says rate of growth. I said growth of great. So rate of growth. Okay, is when something grows, is it changing? Yeah. So when they say rate of growth, that is what we call a rate of change. What was another word for rate of change? Okay, good. So slope. So they're telling you right now that 1.5 is your slope, right?
Yeah.
Okay. Now, remember, we're trying to find the alligator's weight. So y is going to be 1.5x, because x is the number of months, right? So at 0 months, this thing, right now, the way we've got it would be 0 pounds, right? After 1 month, it'd be 1.5 pounds. After 2 months, 3 pounds. After 4 or 3 months, 4.5 pounds, so forth, right? But how much was this thing at birth? It was 4 pounds. So after the first month, we gained 1.5 pounds to the initial 4 that we started with, right? Does that kind of make sense to everybody? So y equals 1.5x plus 4. If I look at alligator 2, it's the same structure then. What should I write for alligator 2? 1x plus 6. Okay, so let's graph those two things. When I graph y equals 1.5x plus 4, what's the 4? Y-intercept, so right there. Okay, now what's 1.5? What do I do with that?
You go 1 and then you go in the middle.
Okay, so you're going to say go up to 5.5, right?
No.
So go up to about right there?
No.
What are you going to do then?
You go to 5 and then go halfway over right.
You go up 1.5.
Right?
Well, remember, it's 1.5 over 1, right?
Oh, shoot.
So I'm going to go up 1.5 units and then over 1. What is the problem with that?
That was 1.5. Oh, yeah, well, yeah.
You kind of got to guess where a half is, right? Well, it's not all that accurate. So now when I got to go up to the next one, maybe it's there over 1, so it'll be that point. Okay? It just lacks some accuracy, I think, in my personal opinion. Okay? What is 1.5 as a fraction?
What?
Okay, so if I have 1.5, think about this. 1.5 over 1.0. That's what I have right now, right? How can I get rid of decimals? Multiply by what? Nope. Can I multiply by 10 over 10?
Why would you do that?
Because is that gonna move that decimal point right there? Is that gonna move that decimal place right there? So 1.5 over 1 is equivalent to 15 over 10. What divides both those? 5. How many times does 5 go into 15? 3. How many times does it go into 10? 2. So is 1.5 over 1 the same thing as 3 over 2? Now, why is 3 over 2 better? Because now I can go up 3, 1, 2, 3, and over 2. Up 3, over 2. Okay? Is that all right? So now, I'm going to connect those. Okay? So that there is alligator 1, right? Alligator 1. Let's do alligator 2. So now it's 6 is my y-intercept, right?
I'm confused.
What's confusing?
How did you even get those ones? I was following you.
Because we had a y-intercept of 4, right?
But there's one point right there.
This one here? That was the one that I went up 1/2 or 1.5 and over 1. I think it was easier to go up 3 and over 2.
Okay.
So that's why I went up 3 and over 2 and got those points.
Okay, I got it.
Okay, so the bottom one is the y-intercept of 6, right? And then up 1, over 1. I keep doing that, right? So now if I connect those, it gives me that line. Let me change its color. Gives me that blue line, right? So where do they cross? 4, 10. Let's talk about what that 4, 10 means. What's the 4? Well, remember what X was? X was month, right? What's Y? The alligator's weight. Okay? So at 4 months, both these things are 10 pounds, right? Does that make sense?
Yeah.
Okay? Before 4 months, alligator 2 is above alligator 1, right? That makes sense? The blue line is above the red line, right? So that means before 4 months, alligator 1 is heavier. After 4 months, alligator 2 is heavier. Does that make sense, everybody? Okay. So the idea, if we go back and go back to like the membership costs, okay, to the left of 4 months would say that maybe the membership is more expensive and paying per session is better. But then after 4 months, the membership is then better and paying per month or per session is more expensive. Okay, so we're going to just change the context of the problem, but it's still the same problem. Okay, we'll do that next story problem. So the next story problem is that idea with money, but I think it's talking about cell phones or satellite radio, like Sirius radio or something like that. And we'll talk about the options we have there. You guys have seen, like, you get online and you get a subscription. Anybody got subscriptions to things online? Like, I subscribe to, like, MLB Network, okay? Netflix, okay? You can do those things on a monthly basis or a yearly basis, right? You can decide which one's best for you.